Ahead and hit record. There we go. All right, and without further ado, Chris Rounds, go ahead and take it away.
Thank you, Kristen. Nice to see everybody virtually here, and nice to see the CORIOLIX out there. Yeah, I'm Chris. I think I recognize most of these names, but some folks I haven't had the chance to meet yet. So, like Kristen said, I work on the RCRV project, and one of the one of our achievements, one of the things that we did, words are escaping me, was we kind of set out at the beginning of the project to develop what we call like a data presence system. So recognizing that telepresence was already a thing, and we kind of data presence was envisioned as kind of maybe like a step back and say, hey, we have to transfer all of this data in order to have a telepresent event, right? It's data that's going back and forth, but we weren't sending the scientific, like the observational data. So like the project was to focus on how do we get observational underway data off the boat and into user groups shoreside, right? So that's what we're going to talk about today. Let me share my screen here. I am going to switch over to so I gave myself like half an hour at the most of kind of PowerPoint. Apologies, but it's like kind of necessary, I guess. So we'll just start off with who are we? I already told you who I am, but there's really four other people that have played significant role in this project. Jasmine is probably who everybody knows. She's the lead developer, and she kind of takes the lead on communicating with our operating vessels and stuff. So if you haven't had a chance to work with Jasmine, she's really great, very dedicated and thoughtful, and her fingerprint is all over this project. James Kaysen took over for Katie Watkins Brandt when she left to go to NOAA. She was our sensor system engineer. James kind of came in, we call him a design specialist. I don't know what exactly that means, but he's functioning as our sensor system engineer, kind of in Katie's role. So he doesn't do direct development work on CORIOLIX, but he is a kind of a tester, and he has a lot of input for us. Tristan King is the newest member, and Tristan was hired late August, I guess. He started in August, and Tristan came on to help us get ready to work in the NOAA fleet. And so he kind of jumped right in, looking at our code base and kind of trying to migrate it to something that could work in the NOAA cloud environment that they have. So he's done a bunch of work kind of on getting ready for Docker and deploying on different operating systems than just Debian Linux. But anyway, he's going to be, he's also covering a couple of the academic research fleet boats. Right now, he's kind of the point person for the Savannah. Really great, also great person to work with. So that's who we are. I thought it would be smart, since you guys took the time to answer the questions, that we would just kind of use those questions to organize a talk. Please feel free to interrupt me at any moment. If anybody doesn't like the way we're going, or we're running out of time, I'm pretty informal. So I've got this like half hour kind of slides, and then we'll kind of go live. But yeah, this first survey question, and this is where I wanted to start, because I actually already started explaining this at the beginning before we got to the slides. But I was interested in knowing how often your science parties ask for remote participation, as part of their crews. And the results, I mean, from the people that responded, which I'm not sure is a cross section of the fleet, but most, I got a lot of nevers, or maybe once or twice a year. And I think if we dug a little bit about that, like, that's basically the problem. Like, as I said at the beginning of the talk, or this meeting, was that CORIOLIX was really envisioned or designed to address a problem of remote participation, and specifically the regional class vessels. Berthing is a real limitation, and there's nothing you can really do about it. to get more people on the boat. So, you know, the NSF wanted to, what's the right word? You know, give shoreside participants some kind of power to work with the seagoing team, right? And so that's kind of, we didn't set out to develop a data acquisition system or anything like that. And we're going to get into that in a moment. But it was really the vision was to deliver data feeds to shore and provide an environment for scientists, you know, to discover data or and work with it. Okay. Another question was, what do you run? What are you currently running for viewing real-time and underway data? And I think the takeaways from these responses might be that there is really no standard either required or in the survey. You know, observe. I'm not sure that's a bad thing, but you know, 16 folks responded, and we identified, you know, 5 or 6, depending on how you count. I don't know, or my own app, unique visualization system. So clearly there's a lot of diversity in how we're presenting real-time underway information to our onboard and I guess our shoreside users too. And I guess just kind of to think about it, it's like, I'm not sure if there is an expectation of a standard from our users. I think there is. I think science parties that are coming on board might expect to see kind of like a common experience across vessels. Maybe they don't. I think you guys could tell me more about that. But you know, our hope is to be able to deploy CORIOLIX to more vessels and kind of start fostering that or supporting that kind of a more standard kind of way of viewing things. I think it's a benefit. And what else we got here? Survey question. Oh, another survey question. And this one is what I'm gonna, you know, is to, are you interested to kind of go learn how to run it? And that's people, I mean, it's kind of leading question. Yeah, sure. So we're gonna do a demo about that. So just we'll come back. We're actually hands-on. Yep. There was another question about if, you know, would you be interested in taking a look at the source code and talking about, you know, how to collaborate. So I think we'll do that afterward. I did want to use that question to kind of talk about the open source project of CORIOLIX and kind of where we're at. So we have, and I mentioned this a couple of times in different RV techs, but I think it's important to get it out there that, you know, we have a commitment to open up the repository and let people contribute. You know, that's always been the plan communicated in our project execution plan and talking to our program managers stuff. But we had our project execution plan for RCRV kind of ties that publication release date to delivery of the first vessel. And we're very late in delivering a vessel to the fleet. So we've kind of got caught in this, well, you know, the dates just kind of moved right. And that's becoming a bit of a problem, and I think is a barrier to working with people. So over the winter, we had a lot of, I met with OSU General Counsel and we looked at all the different binding contracts that may have funded all this work, and came to the conclusion that we can collaborate. You know, I can open this up. I can open up the repository without getting anybody too worked up to the vessels that are already using it. So, so that's kind of going to be the plan, is to work with the people that are currently, you know, operating CORIOLIX, and then if they want access to the repo, we can make that available before the delivery date, and as kind of a way to get people engaged and not keep pushing the date right. So the things we were working on, some feedback I received after our VTech, and actually directly from Eric Grubel, was that we really need to like a roadmap that shows what we're doing and what's coming and where we're at. So I took that back from our VTech and was thinking about it, you know, not too hard. I mean, that's a great idea. But I realized that we really needed a governance plan. And so we've done some work on that. So we've drafted a plan to kind of like, how are we going to make decisions and choose directions, and what privileges are we going to offer developers, and how are we going to handle pull requests and things like that. So I have a draft governance plan. Right now, what I hope to do is organize a body, to function as an oversight body, so we can say, all right, let's get this plan kind of approved, and get official members. And the proposal is to say, all right, all operators are kind of de facto members of this oversight body. And so I'll socialize that kind of plan with operators in the coming weeks, and kind of taking input and stuff. So the 2 points I'm trying to make here is, one, we did some research. We kind of broke down a barrier to collaborating with people, and we're getting our house in order so that we can manage input from contributors when we are kind of officially public at the delivery date. So just wanted to, I'll show you what the governance plan and the roadmap looks like when we got out of PowerPoint here. That was a lot of words for one slide, sorry. I wanted to take that, again, another opportunity here, since we're talking about kind of a project in a bigger level. We have funding from the academic research fleet. We receive funding once a year, kind of like annual installments as a specialized service. So I don't know what that means for the next couple of years, but I think it's like good news and less, right? What does that specialized service do, right? Other than offer the software. What we told NSF we wanted to do was commit to maintaining the code base to be secure, for one. So we've done things like work with, I've done this a lot in the NOAA avenue, but I'm also talking to trusted OmniSoc, but working with kind of the parent institution to deal with any kind of security concerns and policy around. That's kind of what this bullet is. The regular and scheduled maintenance, say, okay, make a commitment to manage our dependencies. So, in GitHub, we do things like use Dependabot to make sure any library that we are using, if there's a CVE for that library, we get a notification, and then we have a kind of a default policy right now to immediately address anything that's critical. And then we're kind of working on, is it reasonable, like 30 days out, to deal with, something that's not critical, but, we may be vulnerable to. And so kind of like a tiered level of how we can, so that we don't have to address every CVE in case it's minor, right? But we're tracking that so that, when we report back to program managers, that we can kind of report out on what we've done in under these areas. And then the code development is a really important piece to commit to too. It's like, okay, we're committing to listening to the users and carving out some time every quarter to working on improvements that are, suggested from users, right? Not just ones that are on our favorite list.
Hey,
Other,
one second,
Good.
Chris, can I jump
Yeah.
in?
Yeah.
Can people see Chris's screen? I got one participant that reached out, said that they couldn't.
Oh my gosh.
Oh, okay, just kidding. I think they're good now.
Yeah, that would have been
All right.
strong.
Sorry about that. Continue, Chris. Thanks.
So basically we're saying we're gonna, commit to, working with your security team, commit to regular and scheduled maintenance. So we'll talk about that more about in a moment, and also commit to monitoring the systems. Some boats are able to do this for us, and we don't really have to monitor disk drives and backups and stuff, but some boats we do. So it really depends on the group. We're still working on, we've recently adopted a weekend coverage kind of schedule. So Jasmine, Tristan, and I rotate every weekend so that there's somebody at least online that can say, hey, you know, how bad is it? Do you need us now? Or we got this on Monday, but that's new. We just got that going last month. We are doing a lot of work. So on a project with Ravel right now, we are basically remotely doing all the metadata entry and setup for CORIOLIX. We like to have the technicians do that. That's what we did with CORIOLIX. You know, Carmen and Steve Roberts put a lot of time doing that, but we've got some improved ways to do it with, you know, bulk uploads of information now. And so we're trying to take on some of that responsibility to get people up and running a little bit faster. And of course, if you're having a cruise that wants to do some remote participation and you want to use CORIOLIX, then we want to be there to help you execute that, right? So I don't know, that hasn't really happened much yet where it's been Science Party has been interacting. I don't know if that's because we haven't pushed it enough or what, but you know, if you're starting to hear things like that in cruise planning, you know, reach out and we want to figure out how to be around for that event and make sure it goes smooth. Okay. Last question. I think we're about done with the survey questions. How comfortable are you reaching out? I think everybody else was, or everybody that answered was fairly comfortable. But some of the feedback was, you know, hey, can we have regular check-in calls? I mentioned that I think I mentioned that we have just started scheduling kind of a preseason. The idea was a preseason, a mid-season, and maybe an end of season check-in call, more if needed. We're having the first one with Savannah next week. I don't know how well that's going to work for global class ship where crews are going back and forth. We try something else, but I've at least reached out to all the tech managers on operating ships and said, hey, I want to do this. Let's get it scheduled. Yeah, knowing what resources are available has been a little bit of a problem and definitely would help you with your comfort. I will admit that our user documentation is lacking. I put it on the roadmap for Q3 update to deal with, you know, anything that was missing or out of date. I acknowledge that. That's a very good point. You know, maybe a wiki or some project web page that kind of presents the bigger picture, who's using what and where to go, is overdue and needed. So thank you for that. Somebody said they just need to get some hands-on time. I think that was always a good idea. The biggest struggle, incorporating it into everyday usage. I'll admit that one kind of hurt. I mean, good point, but I need to talk to you and find out and dig a little bit more about that. You know, tell me what's the struggle. Is it you know, what's opaque and why it's not working for you? So please get in touch. Getting all the metadata, calibration dates, instrument categories into a report. That is in progress. Jasmine's leading an effort to do this. And I neglected to check in with her before the meeting, but there's a pilot that we're working on with a vessel, I believe it's CORIOLIX, to do this basically report generation. So I will, I think we can, if we do better at informing people about where stuff is at and what the roadmap looks like and create a website, we can publish these notifications more and keep people aware. So I think, you know, if you're interested in that, get in touch with Jasmine, and if you have thoughts or requirements specifically about what you want to get in that report, now would be a good time to check in on that, and we can take some notes on that. Somebody mentioned remembering whether to upload calibration docs as a reference sheet or a calibration file, and not being able to assign a document to multiple sensor models. These, I totally get it. You know, there's a little bit of a learning curve with any new technology. We are interested in refining the terms that we use and making it easier. So kind of knowing what is confusing is really helpful. I guess I would to directly answer that question, you could ask yourself, if you're uploading a cal document that has coefficients in it that you're going to need in you want to parse out of that document, then then load it as a CAL file. Otherwise, it'll just get stored in the database as a kind of an image or something. So that's the direct answer, though. I don't think that's the reason somebody mentioned that. I don't have an update on what the plan is for assigning a document to multiple sensor models. I know that is on our issue list. It's been raised a couple of times. I'm not sure where it is in the queue of addressing. But we do, okay, if we can bring operating groups, into the GitHub kind of environment now, you'll have a shorter path to creating an issue, and like it'll be more streamlined for us to know there's something you're looking at. But I'll show you when we do the live demo that there's a place that you can use this kind of interactive tool on the website, and it'll send us an email that somebody contributed some feedback. So that's a good way to get things on an official list. Those lists kind of all feed this giant Asana project.
Hey, Chris, we got
Yeah.
a question from Karen Stocks. She
Yeah,
asks, will the metadata report be in a machine readable format? Please.
yes.
Okay.
I know we have some working metadata in an XML format, but yeah, if you have a preference, a requirement, example, template, schema, send it along. And yeah, but yes, Karen, I think Drew and Jasmine keep in touch on this, on that topic also. And same with Sean. They've all kind of communicated on the various, Samos has a slightly different metadata daily summary that they like. So we had that already. And then I believe that there's a more detailed one that she's working on now, a more general one. Okay. Ships that are, this is a great question. For ships that are all part of the same program, such as the RCRV or SIO, or maybe, UW, people that have support multiple vessels, will all the sensor metadata already be available following for the ships so that they can share, or will we have to re-enter? The simple answer is yes. We don't want to create a giant re-entry. So for RCRV, the Marine techs at OSU, Jasmine, Katie, myself, we've populated the database for each vessel with all the sensor information. So it's ready to go. But if we want to dig a little bit, at the basic level, anytime we discover, somebody introduces a new instrument into our universe, we're going to have to create some metadata for that instrument. So it's like, you really only need to do that once. If it's the same make, model, and it does the same thing, you can copy that metadata and then update the fields that you need to update, serial number, firmware version, whatever. But you can start at least with a mostly correct, export of the original device. Same kind of problem or same kind of situation with parameters that sensor, that instrument might collect, right? If it's a new one that we don't know about, somebody's got to enter it in at some point. But we should be able to use the copy and export tools to make that easier for, if you want to. So I'm working on Ravel right now, and many of their instruments we've seen before on Tani. And I didn't do this, but I could have gone in and exported a lot of those metadata records for those known sensors and pulled them in and just updated serial numbers and stuff like that. We decided for Ravel to work on a spreadsheet, and we have scripts that do the data population, but there's options for making that easy. What was included in the newest update? Again, I think this is what the roadmap will help us with. It'll at least let you know what's on there, and it'll have a status of what's complete. I think maybe a message, a notification email to the users would be a good way to handle this also. I guess the latest, to answer the question, the latest what's new in the latest update, I think the largest thing would be the using the timescale database extensions on Postgres. That this latest update was when that was rolled out to all of our production systems. A new fun feature that could have been rolled out at the same time, but we're still improving is we've replaced, we don't plan to use high charts anymore as our charting toolkit in the web interface. We've rewritten that with Apache eCharts. So that was the high charts licensing was questionable for users. So that was something we addressed by switching gears. And so that'll be really nice. There's a lot more functionality in these new 2D, time series plots, better scaling, sliding through time sliders and stuff like that. So it's a bit of an improvement. Okay, the final bullet I think is we'll just end on that, and then we'll go to some live stuff. How's my time? Anybody looking at?
Yep, perfect time.
Could you tell me what time it is, Kristen? I do not have a clock on this.
It's 1:57 where I'm at, so you've been going for almost a half hour.
Perfect. I was trying to get out of this in a half an hour, so we're on track. So this is many people have spoken up and said, I'm confused about OpenRVDAS and CORIOLIX. I just don't understand. Are they mutually exclusive? Do they work together? Do they do the same thing? So I want to dive into that for a minute. We'll stop here and say, well, before we start talking about differences and similarities, let's just say, what is CORIOLIX? I said at the top that, the problem we're trying to solve was get observational data off the ship. So, somebody can take data, make information, send it back to the ship, they can act on it. I mean, we don't need any other, that's a good enough use case, right? To do that, we need to be able to manage how data acquisition works. We may want to modify the data. We might want to do some processing. We need to manage where files are moving to, where feeds are going, and we need to offer data services, so that we can start building function into that. So I would say CORIOLIX as a software application it integrates operation and management in like these kind of big blocks of scope. It's not an acquisition system. It's not a standalone processing acquisition system. It works with a data acquisition system. It can process data, store it, synchronize it to ship and shore, and provide you a user environment to work with it. If anybody has a great one-word explanation what that is, I would love to know. But let's talk about CORIOLIX and OpenRVDAS. Pablo came up with the image on the right, and I asked ChatGPT to render it for me. I don't think it's a great analogy, but it's somewhat of a cowboy and a horse. You could think of it that way. Don't think too hard about it. I just thought I just want to see what ChatGPT would do. Let's start at the bottom, this lower box. OpenRVDAS. I guess I didn't get my bold perfect. Oh, maybe I did. Anyway, the first thing I want to think about when we talk about OpenRVDAS is think about who uses OpenRVDAS. I think it's safe to say that pool of users for OpenRVDAS is limited to being technical marine, the people that have the team that has responsibility for acquiring the data, making sure that the underway data is well described, collected, and passed on to the science party and R2R and the repositories, right? And I think that's good because, I would say on the CORIOLIX side of the house, CORIOLIX has a much broader users that can interact with it. We do need we do, I mean, Martech's may be the main user, and it's definitely who we're focused on and spend most of our time working with, because it's so, you know, it's integrating a lot of it's embedding itself into your responsibilities, right? But the pool of people that can work with it is bigger than that, because CORIOLIX presents a lot of services that are designed for scientific end users, you know, 3D visual or 2D visualizations, maps, APIs, data downloads, filtering, querying, binning, all, you know, those are products and services designed for Science Party, or either ship or shore. So I just kind of want to say that one difference is that CORIOLIX is trying to serve a larger, I would argue, a larger pool of users. OpenRVDAS at its core provides a suite of tools, right? But there's three core things that it does really well. It reads, it changes, and it writes. So if you have instruments that create data, the reader functionality allows you to talk to that instrument. But, you know, whenever you're reading data, you probably want to store it. So it has writing functions. And so there's a good library of function reading capability where it can talk to serial instruments, you know, like I have here, serial UDP file, Modbus, very capable. And then that transform piece allows you to actually do some work on the data before maybe you write it again or you read the next thing. That's very powerful. And we didn't, you know, one of the first meetings we had was with Bob Arco, you know, back in 2015. And Bob said, please don't write another data acquisition system. We already have enough. And we found ourselves starting to do that. And thankfully, Pablo came along and, you know, had this vision for a very modular system. Also provides us a nice framework for, you know, control, you know, you can build a logger and run it, right? So it's got those three core features that you can put together to do some amazing things, and also have, you know, a framework to keep it alive, turn it on, turn it off, change its mode, right? So we use CORIOLIX to collect information about all the instruments that we have, right? So whether it's in use or it's on a shelf somewhere, the histories of those instruments, the calibration files for those instruments, what state we want that instrument to be in, you know, how we want to feed the data into our access and visualization services. And CORIOLIX then configures OpenRVDAS to do what it needs to do to make that work. So I think that's probably as deep as we need to go. You know, if you, I would say CORIOLIX at this point depends on OpenRVDAS. We can work with other data acquisition systems like SCS is one. You know, we have a long history of getting data out of that, but it's limited. We can, you know, CORIOLIX can sing a nice song with OpenRVDAS, and it's really hobbled with anything else. So it's been, we've really bought into OpenRVDAS. Alice, I see you have your hand raised.
Yeah, so if somebody were to have CORIOLIX installed or get a CORIOLIX installation, I mean, it basically, this is very simplified, but an OpenRVDAS instance would come with that, right?
You would, yes, you would. I would suggest that we do that. We don't have to. We have users that use SCS and do not use OpenRVDAS. We feel like that's a dead end. But
But for those newer folks, right? Yeah,
yeah,
that potentially aren't using. Yep. Okay.
yeah.
I just wanted to make that clear. It's not like you had to go out and find OpenRVDAS. There would be assistance in getting all of that set up together, right?
Yeah. The installation script basically calls, leverages. So OpenRVDAS is publicly available. Ocean Data Tools, Webb's here. I think he could speak about this if he needs to. So we use the standard installation for OpenRVDAS right off so we don't maintain a forked or cloned OpenRVDAS. We maintain, we need one little piece of special sauce. So we have a CORIOLIX / OpenRVDAS module that then gets installed that allows them to talk to each other. Yeah, and we would install it, and then CORIOLIX would configure it. So yeah.
Great.
Yep.
Thank you.
Is there any, does anybody want me to go? Are there any other like lingering confusions about OpenRV? I see a hand. It looks like Julian. Is there somebody waving on the Seculiac?
Yeah, this is Jason on the Seculiac right now.
Oh, hey, Jason.
Hey, I have a quick question about applying calibration coefficients to sensors. You know, before getting the data output. Is it recommended to do that via OpenRVDAS, or does CORIOLIX also have that, you know, that capability and function? Is there any sort of guidance on what would be the best application of those cal coefficients? So I know we save them as reference in CORIOLIX for users now, but just curious about that architecture.
Yeah. So what we would recommend is, and what works, say you receive a calibration file from Seabird. Jasmine has a workflow. I haven't done this in a little while. A workflow that imports, like reads that file in, parses out the calibration coefficients that are, you know, needed to do a calibration for that instrument, that specific instrument. So those get saved as the valid calibrations for that instrument, right? The current calibrations. We wrote for all of the instruments that we do a calibration for, we either wrote or somebody else provided us with some Python code to actually do it. And so we made an OpenRVDAS transformation module that each time a data point comes in, it will grab the calibration coefficient and anything it needs out of the CORIOLIX database and run that calibration in OpenRVDAS. So I think I gave you a kind of a complicated answer, but you said that I'm inferring that you may have done something manually in OpenRVDAS to make that work. I'm just saying that there's a way that it's very streamlined. If you bring in a new calibration file, say you activate a new instrument that came back from Seabird, okay, that's enabled, the calibration file's loaded, it's parsed, the values are in the table, then it'll, every time it needs to do a calibration, it just looks that up. I know that's a lot of lookups, but we're
that's great.
We're trying to set up for when they change fast.
Okay. Yeah, no, that's helpful. Thank you, Chris.
Yeah. We're gonna, if anybody, I don't know if we need to stay here, but if you haven't thought about what it is underneath the hood, it's basically, you've got two boxes on the screen. On the left, I have what we're calling stuff on the shipboard components. On the right, we have stuff on the shore. The rectangles in each of those, regions are virtual machines. So there's 4 virtual machines in this picture. On the left side, on the ship, at the top left, you can see data arriving at our first virtual machine. So in the case of a system, a boat that was spitting out UDP data from a GPS sensor, say, it arrives at OpenRVDAS. This is the OpenRVDAS machine. These are some of the different, I developed this drawing for somebody else, not exactly for this. So there's too much on it for what we're doing right now, but OpenRVDAS saves that data locally and only annotated with time and instrument ID. So not changed, annotated. That's the just in case copy, or whatever your data management policy might specify. You need to have a copy for X many days in a safe place. That's where it goes. It can be harvested by, we can move it, or OpenVDM can get it. The data then moves to a database where, so we maybe split it up. We put it into a table. It lives in a database. It goes to shore via a different pathway, We do not replicate data tables between database to database and keep them in sync. It's really chatty and we haven't got it to work over satellite links. Instead, we make a publication. Every instrument gets published to a topic. The topic is like the vessel. So it'd be CORIOLIX and then instrument, whatever. On the shore side, we create a subscriber to that publication. So we are just sending data as it arrives to shore right now on a fire and forget kind of a basis. So it might not arrive at shore if you have a poor connection. You can increase the quality of service and force it to arrive at shore, but it's going to take more bandwidth. So that's weird. I might, because then we have to reparse it and insert it into our database in order to give you the same experience on the shore side. But that design was kind of driven by trying to utilize utilize the link as efficiently as possible, right? We could have just I told you we tried to synchronize tables and that killed the link, and it actually didn't work very well. It might work better on Starlink. So in the back of your head, keep in mind that you need infrastructure on the shore, infrastructure on the beach, and they're identical systems for the most part. We can skip over the minimum requirements. I think that would be, so I got out of the presentation a little longer than I had hoped, but we're going to switch over to a different PowerPoint if I can get this reshared here. All right. Actually, I'm going to switch over to the desktop and I'm going to just follow along on the PowerPoint. So I know what I'm doing. Share. Let's go with desktop. Nope. I think I want to go. Sorry, I'm talking out loud. You don't need to hear that.
Good. Does anybody have any other burning questions while he brings up the demo?
Yeah, exactly. There would be a great time for a question.
What's the learning curve been like on the ships in terms of time?
That's a great question.
Yeah.
Some of the, you might ask some of the CORIOLIX staff to answer that. Does anybody out there want to be honest and say how it's been to go from 0 to 60? Well, go for
Could
it.
you repeat the question one more time, please?
Yes, what's the learning curve in terms of time been on the ships to get into it and use it?
We're using CORIOLIX.
Yes.
We use it on the Endeavor, and I as a tech, it's one of the first things I open up in the morning just to get a sense of how my sensors are doing. I think we've had a little trouble on the science side just because a lot of our science are repeat customers, and so they're used to what they're used to. And so to get them to use CORIOLIX on a daily basis has been that uptake issue that Chris talked about. But on the tech side, I find it pretty intuitive. I find it fairly easy. I mean, the calibration thing is one thing we're working on because we do use SCS as primary right now. Obviously, we have CORIOLIX and RV-DAS also on board, but I think just from a user standpoint and some integration of sensors that I've done with Jasmine, it is. I'd say it's fairly easy and straightforward. One thing I would like is a more user-friendly interface to be able to add sensors and calibrations, so we don't have to lean on Jasmine and the team right now. But I know that's probably that's coming. But yeah, I'd say overall we've had good success with it, and we use it fairly frequently.
Thanks, Jason. Appreciate that. Alice, I noticed you have your hand up.
Too much. I guess I'm curious to hear from some of the smaller vessels. Grace, you're here. And I guess, and Grace, please correct me when I'm wrong, but I had heard that either the Pelican or the Point Sur was super interested in continuing with CORIOLIX, which makes me think that they'd that it can't be that hard to use because they've got such a limited technical staff. So, and I don't mean that just because you're short on people, Grace. Do you have any thoughts from a small ship perspective?
Hi, Alice. You're certainly right on the limited personnel. I do enjoy having CORIOLIX on board. For me, it's kind of something that I'll look at maybe at the beginning of the day, or midday, just check in on it. But truthfully, a lot of scientists, we don't really much have a need of that kind of telepresence when it comes to the data. And
Mhm.
on board, I run SCS, and so everybody's just looking at the data through SCS. I think
see.
I've given out CORIOLIX and CORIOLIX's information maybe once or twice a year. But for the most part, it's just for my own personal gain on and insight on the systems.
And again, you feel like that's because that's what those scientists are used to, right? Is that what I'm
Yes,
hearing?
at this point, the
Yeah.
majority of the people that come on board, they come on twice every single year. I don't get a lot of new people anymore. And this is just, it's what they know, is what they're used to. Absolutely.
Yeah. Okay. Thanks.
Yeah, we have not, reaching that. I guess I need to be going to like ocean sciences and talking to the, I go to RV tech and talk to techs, and I don't know if we're hitting our mark, talking to the science community, and I think one of the things that we may have held us back was, I think we approached it as like a giant beta test for a long time, especially with Grace's team
Nice.
and Endeavor. We didn't really, for a long time, we didn't want any, but it had warts that the scientists would see immediately, like too many significant figures or something that sends somebody into the corner. So we need to do better at, like, I think that's next. I mean, to be 100% honest, I felt like if the techs don't get it and can't use it, then we're dead in the water. And so we have spent pretty much all of our effort working with the techs, and I have work to do with like the science folks. I know it. That's something that
But I think you're right, though, Chris. I think that was the smart approach because the techs have to buy into it and get it on the ships, and then is once it becomes regular on the ships, they have no choice, right? We don't have to keep two systems running forever or whatever. You know what I'm saying? So
Mhm.
change is hard for some, but it's often necessary.
Well, we don't want to lose anything, and that's, I think, if we, we're looking at making sure we're, if we're going to switch over. I see your hand, Webb. I guess I'm finishing this weird thought, but if we're going to switch over from one system to another, we got to make sure that, we're not losing some key piece of diagnostic information or something like that. And I think we're getting close. Webb, go.
Yeah, can you hear me? Hello?
Yep, we can
We
hear
can
you.
hear you.
Okay, just check. Yeah, Chris is someone, who's been doing this for 20 years now. I've
Oh.
I've just basically accepted that the greatest analytical tool in the science community will always be Excel. And so I think because I've gone through many of the same exercises that I see CORIOLIX going through. And ultimately, unless they come to the table with some specific homegrown engineering processing workflow in mind, they're going to want it in CSV. JSON, if they're sophisticated, one use, MATLAB or Python, Pandas, whatever. So it is going to be a tough sell. So that struggle is going to be real. On the ship to shore side stuff, I mean, like you said, the name telepresence was already taken, and that was me and a group of people. It's tough unless it's a very live sensitive environment like an ROV dive. It's very tough to get active shoreside engagement over, and enthralling engagement over a time series data set. It's a tough sell.
It is.
So don't, anyway, I can commiserate with that. And it also it's interesting to hear the people that have chimed in kind of echo exactly what the techs are saying when I started, doing that 15 years ago of like, yeah, unless it's a specialized group, people go to sea because that's where it happens. And if they're not on the boat, then it's just, it's not important. It's probably more important, and this is a lesson we learned on Okeanos, it's probably more important that they get an accurate operations, like end of the day report detailing exactly what happened, problems. That's actually, I think, goes further in promoting shoreside engagement than a visualized time series data set. So
Yeah.
my opinion.
I think I know of one paper that's in process, or in their manuscripts in development. Like my vocabulary is just like not here today. So Ian Black, he used to work for OOI, went back to grad school. He's in a PhD program now. He and Anna Hughes, they're both graduate students on RCRV. They're working on the PCO2 system. They did a comparison between two PCO2 systems, the RCRV PCO2 system and the CORIOLIX, and they did it all from their office, and working up. They did it all with the help of the awesome team on CORIOLIX from their office. I know a lot of the techs helped them out, but they're going to have a paper kind of on this comparison, and they, made the point to kind of discuss a little bit about being able to do it through kind of a standard API, asking, submitting queries and getting information back. So I think if we can get some of that stuff out, we'll start generating some idea in the science community. So yeah, I will, that'll be something when the manuscript is ready, after Ian defends and publishes, I will get that out on the new notification channel. Okay, so we've got about half an hour left. I could do a little demonstration about what the different functionality is. Go through kind of the difference between being a public user and a tech user, somebody with permissions, or we could look at, how to check to see things if things are running. Is there anything that somebody wants to see in the live demo before I start clicking buttons on the screen, I guess is the question. Okay, I'll give it like I'll do a little, okay. I'll just go with the plan. So what we're looking at here is the web page, the user interface that's running in Fairbanks, I believe, in a data center. So this URL, https coriolix.seculiac.alaska.edu, is exactly the same page you would see if you were on the ship and putting in a similar URL, but it's coming. So since I'm in Corvallis, I'm not, the vessel is not feeding any web page to me, right? I'm interacting with the shoreside site, and I'm not logged in, I don't think. Yeah, I'm not logged in. So I'm kind of here as a public user. Just wanted to draw your attention that anybody on your vessel or on your vessel, if you're using this on your vessel or if they're on shore, can kind of see this page and can kind of can see a lot. They might want to check in and see what's going on. This view shows us in kind of like a block view here, a grid view, all of the instruments, or what we call sensors, on Seculiac. A couple of them are red. Why are they red? If I hold over it, the little pop-up is telling me that we haven't seen data from this instrument in a while, 15 minutes. At 15 minutes, you can tune that to whatever you want. But what I'm showing you is there's an alert, there's something watching and looking for a condition and reporting that there's a problem. You can set up however you want, what warnings level it is and what the time is, right? There's a framework to do that. You can click on the problem and it'll redirect you to the data page for that instrument. And I can see, yeah, it's been a couple of days week or so since there's been data. Maybe they're not in 710 depths and they're using the other multi-beam. You could take a quick look and see, not by instrument, but by actual parameter. looks like everything's looking pretty good. There's a couple of them that aren't coming in. I'm not sure why, but we'll take a look. Oops, I went too fast. What's the warning say? No flags. For some reason, flags aren't being computed on this. So that's somebody wanted to know that and wanted that to be represented. So some quick kind of like how are things going views. The other thing a public user can do is take a look at your sensor list. So I want you to know, if you cook it all down in CORIOLIX, there's a table for sensors and there's a table for parameters. So every row in the sensor table is an individual, by serial number sensor. And same thing when a parameter in the parameter table belongs to that sensor. So, you might have sea surface temperature as a parameter or water temperature as a parameter many times, but it's unique to that and it has a unique ID so you can really, so everything's kind of traceable. But knowing that kind of helps you understand why is there a parameter page and a sensor page, right? Sensors have parameters, one or more. So just kind of background. When you're looking at this page, you can see gray rows and white rows. I'm not in love with this. I think gray rows should be invisible. They're the ones that are not active right now. But the world does not work according to how I like things. So no, I'm just joking. It's just, we've been taking input on, we haven't found the exact perfect way to look at this yet, but it'd be nice to at least hide the ones that are not active. That's on my wish list. But what take away from that is, on CORIOLIX here, they have many different altimeter or 3 different altimeters here. The white one is the one that's on. So maybe that's not a good one to look at, but let's look at the Seabird, this instrument. Please put in pictures. Every instrument has, a little page that tells you about it. We can put a picture of your instrument on this page, on the wall with doing its thing. So, that's just something that we can do. I miss it when I don't see it there. Just a basic metadata about the instrument. If you log, we'll show you more when you log in. There's information, or there's under the data tab, even if you're not a user, I'm sorry, if you're not an authenticated user, you can still access data. So if we went to the, data download, it should, there we go. This download interface is leveraging an ERDAP data server on the back end. So if your users or yourself, you're familiar with ERDAP, you don't have to go through this page and download anything. You can, use the capabilities that ERDAP provides. But this was an interface that we developed to kind of abstract so people don't have to deal with ERDAP. And it has like the top level things we thought people might want, being able to either do a default, what did I click? I clicked on bin data. So we're giving you the option to choose between a 1-minute bin or a 10-minute bin. That's what happens to be what the cruise specific bin is in this case. You can choose a range of days or enter a unique range of time, and you can choose different output formats. There are more features at the lower level ERDAP interface. We're just kind of seeing how these work. So for the quick and dirty, if somebody needs to come and download a data set, you can point them here. You have full control over what parameters right now everything is selected. If you have users that write code, and want to run things on a schedule, you can reveal the underlying URL that is used to do the query to get that data, and then put that into your code. So just, pretty low, unauthenticated, if you're on the ship, you're there, you're part of the team. We do have a way to, restrict data sets from this public view or public download if there's a reason for that. So maybe you don't want anybody to know where you're at because you're on a shipwreck. There's a way. We don't have a great interface for it, but if you work with us, we can set it up. The back end's there to make it invisible and basically hide that so that you wouldn't be revealing where you're at, or that's just an example. But you can that's on the roadmap for more control over that. What else do I have? Cruise tools is a nice one. We harvest cruise information from the Marine Facilities Planner. I'm not going to hit refresh right now because I didn't test it. And I don't want to mess anything up, but I believe, let's see, we are up to date. We are out. Yeah, it looks, somebody refreshed it because we've got cruises all the way out till the end of the year, it looks like already. So, we're pulling cruise names, ports, and some basic personnel information. We can build this out, but that at least gives us a way to superimpose a cruise onto what we really like. We think of data collection without reference to cruise. In CORIOLIX, it's just on. If you can reconfigure it, you can turn it off, but there's nothing wrong with just the data is stored in data tables with time, and your cruise start and your cruise end are free to change with reality. And when you're ready, you can package it based on a start and an end time. So we don't yet, so I'm going to qualify this, we don't yet do a lot of building out a bunch of directory structure and naming convention and anything like that. Because we, our source of information is inside the database. And I will say, and this is just a preview of the future. We talked about OpenRVDAS as a tool that CORIOLIX works very well with. Web also develops a tool, supports a tool called OpenVDM. Some of what I just said that we don't do, enforcing naming convention and stuff across other systems, external to CORIOLIX or external to OpenRVDAS, that's something that OpenVDM does very well. So we want to be good collaborators and community members. And so this summer, soon, there's a lot on the to-do list, but we've identified that, hey, we want to learn, we want to look at what we're doing and see if, there are places we can use OpenVDM to do the pieces, the things that it's great at. So I could see a future where all three tools kind of work in concert. We're not there yet, but I don't think that there's any reason that we can't. And I think that it's something that we can kind of approach, collaboratively and figure out where the right boundaries are. So I'll just leave it at that. All right, I'm looking at the time again, which I should move on. I'm going to log in. Okay, so we got a quick feel for what somebody can see, but like, how do you use this thing? You log in. Now, anybody can create an account. If an administrator, once you create an account, it's under cruise tools here. Things move around. Settings, here we go. So, account management. So I should be an administrator. I can see everybody's account in CORIOLIX. And so if a new team member comes on board, they create an account, there'll be the account will be created as public, and you'll need somebody with administrator level to promote them, to the appropriate level. Pretty easy to do through this interface. Then, once you get to a support level, so we're going to jump from public to support, you'll have a lot of additional, additional features will be revealed. So we'll go back to the sensor list, and now I have edit capability and duplicate. That's, do we want to duplicate this record? We kind of talked about not creating records from scratch. More options here. So I'll just look at like an edit. Let's go edit the ADCP. This is something new. Jasmine it was a big page that just scrolled, and she's tried to organize it into little groups. Works really well when you know where the thing you're looking for is. Maybe we'll have add a search, but this is the kind of metadata we collect. Sensor name, a class, we use you know, the choice of class is important because that's how it gets organized into the other pages on the screen. So most of these fields are very important. Things like, yeah, there's a number of controlled vocabularies and stuff that we record for each instrument. So this might be where you would set its status. So, you know, if you're taking it off to send it back to Seabird, you'd come in here, well, not an ADCP, but you get the idea. An instrument that would get sent back or disabled, you know, you can disable it. And what this would do, if I save that disabled, I could recreate a logging configuration that wasn't looking to receive any information from this device. And most likely I went and found another sensor and hit enabled. And so that would reconfigure OpenRV to say, hey, it's on a different port. Oh, it's got a different CAL file, you know. That should be what you need to do if your metadata is up to date. So yeah, basically you can, there's many CORIOLIX sites out there. If you don't know where to find one, let me know and you are free. I can get you set up on a demonstration site actually that we have if you want to start playing, you know, trying anything out and not breaking it. So that's how we would kind of edit a sensor. This is where a lot of the pain and agony is because, you know, why do we have so many metadata fields? Why do we care about, you know, well, we'll go to parameter. Parameters are worse, I think. If we go to the parameters, just give me a sec, I'm switching over here. Detail on this. You know, these are parameters for this Suna nitrate. There's a lot of metadata to fill in, but if we can start completing some of the optional stuff down here, like the range, global ranges, local ranges, then we can really start making the map viewer or even the plots do things. You know, hey, we're out of range. The plot could change color. You know, we can flag. You know, we have a workflow to flag all the real-time information as it comes in, but it requires, you know, information to evaluate what, you know, especially flagging, right? So I see a lot of empty, none, and mins and maxes in here, and you know, I would love to make an effort to work with, maybe that's something that is easy to, maybe we can get like a little tiger team together to go pull some of this stuff out of the various ocean atlases and stuff where, I mean, it's not unfindable information, but I just a plug to put it in there because it's useful. And sometimes when things don't work well in the map page, it's because, well, I kind of need to know, you know, what range to plot and what's not realistic. And oftentimes it's not there. One of the things as a user that I want to point out here is the message parsing. So most everybody's familiar with, you know, data that's being spit out of an instrument. Oftentimes it comes as a, you know, somewhat human readable formatted ASCII string, right? Like you think of a GPS GGA message, right? You know, it's got a talker ID and the sentence format and all this stuff. One of the things that any system that needs to work on that data needs to know is what that format is and how to parse it, how to divide it up and identify the various components of that message. So we leverage regular expressions to do that and a Python library for evaluating them. So this message parser format blurb here is actually the regular expression that will parse this sample data message into named variables that we can use in our transform code. So the transform code for this nitrate sensor, you know, is looking for nitrate concentration and is looking for these named variables to do processing. So this has been a pain point for a lot of users because, I mean, I'm not great at regex. Most people would look at you funny just with the word, right? It doesn't need to be a barrier. One of the things, there's a couple things we're doing to make this to help out here. And of course, I'm not going to find it because there's a, when you edit the data format, native data format. There is a verify format button. So here's some sample data messages up here, and here's the regex to do it. We have basically a tester that you can keep working on your regex till it's right. The other thing we have is a GitHub page. Where is it? It's underneath my meeting notes. Oh God, I can't click that. It's so funny. Not sure if I didn't queue up the actual GitHub page. I apologize. There's a GitHub repository that already is public. And I believe Jules may have sent it around, where we are collecting for each instrument type. So, Seabird 43, here's known working regex in a couple different flavors, depending on how you want to name your variables or what you want out of it. So we're basically creating a catalog so that you can do this real quick. You don't have to write these. Maybe if you're writing a new parser that does something different, you could adjust it. But that was something that was really painful when we decided to go this route. So we've put some work in giving you some tools to make it work. Okay. So I am running out of time. I guess I have about 20 minutes. That's the quick and dirty. I think this is just another time to check in to see what folks might want me to talk more about. I don't want to just, I think people have seen the web page probably once or twice, so maybe just a quick check-in to see which direction to go next. Go, Web.
This is something that I'd like to see it done the correct way. This is something that I did for when we integrated CLog to work with CORIOLIX on Schoolyag. And one of the challenges that I had was I wanted to get speed over ground in knots. If you could walk us through the correct way to figure out exactly the right API call to find that, and if possible, because I believe it's in meters per second, to apply the multiplication factor to convert it to knots.
Yeah. If we're storing it natively, okay, so in this, we're talking wind speed, is that what we were?
No, speed over ground.
Speed over ground. Okay, so let's go to sensors, sensor list. So I'll sort by class because we're looking for a nav. The first thing that speed over ground, so it's from a GPS, it's a navigation instrument. Let's look at our CPath. So Schoolyag has a CPath 380 plus that is active. Let's take a peek at that. Okay. The CPath collects course over ground, speed over ground, and in the units of kilometers an hour. Okay. So the API, any call is going to return kilometers per hour. So if you're looking for speed over ground from this instrument, you're going to need to do the conversion to knots in this case, because we're not storing knots, the value in that, in those. Does that make sense?
Yeah, and that's exactly what I had to do. Is I had to code it up to do it.
Right.
Now, but keep going.
Yeah. So your question, okay. So this instrument, if we want to find that on the API, there's many ways to do this. I would go, pardon me, phone was no longer on do not disturb. I would go to download high resolution data. I don't want to subset the data. And I would probably deselect all the flow through, deselect all the atmospheric, deselect the navigation, and just select speed over ground. SOG kilometers per hour from the C path. Looks like I almost forgot to deselect the others. Okay, then I'd scroll back up here and so show the URL. And what this would do is it'll tell you if you go to this URL, I'm not going to do the whole thing. I'm going to just go to table dap, copy. What it's done is it's already specified 1 day at full resolution CSV. That's what's all encoded in there. But you know, you can either modify it like this or you can modify it by hand. But what you need to know is that this URL, the ERDAP server on the back end, you know, these are all the data sets that we're serving with ERDAP. I probably could have, I missed one extra. GNS VTD, VTG BAL, GNS VTD. Oh, so this is silly. I am not writing the, I'm putting the table name here when I should be putting the instrument name. So that would have made it easier, but it's basically one of these endpoints. So you can get it out of ERDAP with that URL, and that's what I would think most science users would want the ERDAP URL, or you can get it from our API by querying the table that it's in. And so that's an improvement that is on our list to do, is to, instead of kind of presenting the data to the user with a table name, which is meaningless and causes confusion, is to have those looked up and overwritten to be an instrument identifier, right? Because a table, generally we do 1 table per instrument. So that would have helped you in your work, you know, in what you were trying to do. And that's a known, that's actually, I just got a report from the same graduate student on CORIOLIX from the viewpoint of FAIR principles. And there's a significant amount of feedback on what we can do in the API to make it easier on users. So that's something that we're going to tackle this summer. I kind of have to when the graduate student puts it in the report. But yeah, I think we got you to the API, or to the API endpoint you wanted in ERDAP, but you'll never get this server doesn't do that transformation. If that's something that we want to do, that could be added to the API call. So I could add that functionality like a unit conversion. I hadn't thought about it.
I get those requests all the time, where instrument says X and they want it in Y. And so typically it involves spinning up a new logger that basically pulls from the cache data server, the OpenRV DAS cache data server, applies the conversion coefficients, and spits it out in the format that they desire. So
I think our approach would be, we really don't like to save the same information twice, and unit, like I want to, our convention is to save it, to store it in what the instrument provided us. And then I would most likely, I mean, I might change my mind, but I would most likely make that an on-demand option through the download. And just
the way I actually ended up implementing it, because I saw it with the CORIOLIX C-log integration, I kind of saw it as a sign of what's to come, is I actually just programmed a modification language whereby you can basically apply an MX plus B type transform, and it's defined within the YAML file. So there's no recoding. You basically just tweak your YAML and then restart the process. And so that's the way we got it to work on Spool. Yeah. But thank you.
That's exactly.
I feel better.
That's totally right.
I feel better now that okay, I feel better that I didn't figure it out on my own the first try. So thanks.
Yeah. I'm trying to remember the name of the Swagger UI.
Yeah, it's Oh, I forget how you guys do yours. But that was actually how I ended up doing, was just brute forcing the Open API docs.
Yeah, there's an open API endpoint that presents the schema, and it will. You don't want to look at this API view. There's a more user friendly, and it gives you the options of what you can do at every one of these endpoints. Unfortunately, we've got debugging off on this system, and so it won't tell me what the right URL is. I just tried to make a mistake. It usually tells me, hey, you got it wrong, do this. Okay, yeah. Any other questions like digging? We got 10 minutes, so you know what I had queued up? I don't know if this is going to be fun or not, but I had one other thing that I don't know if everybody knows about. People that use the boat, so the people like Grace that need to see if this thing is running. I'm going to stop my share real quick here and pop up a terminal window. Okay, start the share. Terminal. Okay, it's kind of ugly. I'm going to resize it. It's white, I think. You guys see that? Okay, here we are. Oh, no. Let's see if we can get back in. It timed out. Okay, I'm logged into the OpenRV machine for the Tawny, so it's running in my lab, and I'm going to quickly log into the CORIOLIX machine. Okay.
Wait,
So
I don't know if it's on my side or your side, Chris, but I can't really, like, I see the terminal window, but nothing.
oh, you're right. Sorry about that. I guess
No
maybe it
worries.
doesn't work with terminal. Oh, it's gonna.
Yeah, they were also saying that Zoom is having troubles right now, so if anyone accidentally logged out, you can't log back in. But that's like a worldwide issue right now.
Oh, shoot.
Yeah.
So you don't see any terminal output?
Oh, we do now. Yep,
Okay.
got it.
I just wanted to mention, oftentimes I need to work with techs, and so we're taking a big right turn here, or left turn, or U-turn, or I don't know, we're getting off ramp. One thing when working with techs, one of the first things you want to do is like, hey, just restart it. Like, let's get it alive again, and then I'll dig into the log files. And so I'll say like, restart supervisor. Some of you may have seen this before. So I'm at the command line on the OpenRV machine. If you issue supervisor CTL status, as sudo, it'll tell you all the CORIOLIX related. So we manage all of the CORIOLIX and OpenRV processes with supervisor. That's the same thing OpenRV was using. So, hey, let's do it the same way. So you can see a number of things that are running in the background here. We've got a build cruise definition kind of job. If we're on CORIOLIX and I forget, you can only see one thing at a time. If we refresh the loggers or we change some metadata and we say, okay, hey, it's changed, we want to restart logging. This build cruise definition job gets called, creates one or more OpenRV logging configurations and pushes them out to where they need to be. So that's the job that does that. Django, Nginx, and Django UWSGI, that's the website. Logger Manager, that's OpenRV. That's the OpenRV web interface. So you can do on the command line here things like supervisor CTL, restart, Django. And you can actually give it, you gotta spell it right. DJANG. No, I did spell it right. Django. Django is named after Django Reinhardt. So that if I issue that command, it's going to restart both the Nginx and the WSGI. So, if you just want to start one thing, you have to write it out just like that, Django :WSGI, or you can use the wildcard. So just wanted to get you the same thing for the CORIOLIX VM. That's this other window. I can do the same thing. What is the you know, there's some slightly different processes running here. You can see that we're doing binning. So we're logging the data with OpenRVDAS at full resolution in the database, but we have a long running binning job, actually 2 of them, that at the end of every minute, we go and grab the last minute's data and compute mean, median, mode, a spot value, you know, and give you all the statistics, you know, and then we do that for like the full or all the data, just the best data that passed your flagging or some, and we also do it a unique combination of flags that Samos likes. So just pointing out that there are these 2 processes in the background that are creating, I told Webb we don't like to keep data redundant copies of it, but we are reducing it to 2 different data products, a 1-minute bin and a 10-minute bin by default. You can adjust that second one. So we are having, and I'll be 100% honest with you, we're having some trouble right now, and we haven't identified where it was. We're having some trouble on CORIOLIX and one other site with out of memory problems that we believe are related to the binning job. It's something changed in the either in one of the libraries underneath the hood. So something in our environment, you know, we're actively working a problem right now. I'll just, you know, be straight up with you. CORIOLIX's been the most impacted. And we're probably going to modify our binning to not run at the same time. And that will, you know, we can do, it doesn't take a minute to do the work. We can be a little bit late on the second run. And that's going to, you know, cut half the RAM requirement down, or maybe more. It'll just doing them, you know, sequentially. And then we're also profiling the query to see if we're doing anything silly that's sucking up a lot of RAM. So I think I'm out of time. And I really appreciate everybody tuning in today. If you need
thank
more
you so much,
information,
Chris.
call. Yeah.
Yeah, we got a lot of positive comments in the chat. I'll send them to you later. But a lot of people really enjoy using CORIOLIX, and it sounds like there's more interest even in the Canadian fleet with maybe some folks.
Great.
starting up.
And you know, I just want, you know, it's open, you know, we talked about OpenRVDAS. We touched on OpenVDM. I think these are projects that can work together, and, you know, I don't know what the future brings with funding and all that. It's not, there's 3 of us. It's a lot of work actually to get a boat off the ground. You know, I hope this keeps going. We're getting some momentum, and yeah, it's just a weird time, but that's enough said.
All right. Well, thank you, Chris, so much. And thank you everyone for joining.
Mm-hmm.
I will definitely post the recording once we have it. Actually, that reminds me, stop recording.